already completed second module, and also we have completed fifth module, that is module from electronics. Okay. So this from this portion, whatever questions I have discussed during revision will be asking for CS exam. So you have to go through those questions. Okay. Now from today we are going to start the third module, that is the module from electrical. So the module name is AC circuit, and what we are going to learn from this module is one is phasor representation of sinusoidal quantity. So normally for sine wave we used to draw complete wave like this. Sine wave we used to represent like this, and when uh, it is very easy. Okay, this is also not a difficult process. We can easily represent a sine wave. But the problem is when it comes to some numerical or if you want to analyze more than 2 or 3 waveforms, then it is very difficult to do the calculations and representation, etc. So at that time, what we do is we will represent this sine wave in terms of a quantity called phasor. So using this phasor, we can do all the analysis very easily. Example, mathematics and addition, subtraction, multiplication. All those things we can do very easily. Okay. So again, I will tell you. First, we are going to learn about phasor representation of sinusoidal quantity. That means every time whenever we are drawing this sine wave or representing a sine wave using waveform, it is very difficult to do the analysis and mathematical operations. Okay. So if you represent a sine wave or AC quantity in terms of phasor, it is very easy for you to do the perform the arithmetic operation, and also it is very easy for you to represent that wave. So that is the importance of phasor. Then we will see what are the different types of representation for these phasors. Okay, then we are going to learn about some mathematical operation that we can perform uh, using phasor. Okay, first we are going to see what is a phasor. Then from that, what are the operations we can perform on phasor. That is what we are going to discuss. Then the second part of this topic is about analysis of simple AC circuit. So if you have a pure resistive circuit, how it will work, pure inductive circuit, how it will work, capacitive circuit, then combinations of inductive, capacitive, uh, and then concept of impedance, uh, then average power factor. Okay, so all these things we are going to discuss. Then all the combinations. So first we will learn if you connect a resistor in an AC circuit, how it is going to work. Then later we will see capacitor, and then inductor, and then combinations of all this. Okay, sometimes we will take the combination of resistor and inductor, sometimes resistor and capacitor, and sometimes all the three if you connect in series, how it will work. That is what we are going to analyze in the later part of the module. And the final part, consider this is the most important section of this module, because you can expect 1 10-mark question from this uh, part. Either it will be a derivation or it will be numerical. Okay. So if you learn this part, I am sure that you will be getting 10 marks. So numerical they will be asking, and also there are 2 derivations in this topic. It is about 3-phase AC system. Till now we were dealing with single phase AC system. In this part we are going to learn about 3-phase. Okay, so that is about this module. It is little bit difficult to understand, but if you go through this, it is very easy. If you understand the concept, you can easily learn all the other topic in this module. Okay, now we will see what is a phasor representation for quantity. Okay, uh, basically a rotating vector. Okay, we already know what is a scalar, what is a vector. Scalar is a quantity which has only magnitude. അല്ലെ സ്കേലർ എന്ന് പറയുന്നത് ഒരു ക്വാണ്ടിറ്റിയാണ്, അതിന് മാഗ്നിറ്റ്യൂഡ് മാത്രം ഉള്ള ഒരു ക്വാണ്ടിറ്റിയാണ് സ്കേലർ എന്ന് പറയുന്നത്. വെക്ടർ എന്ന് പറയുന്നത് ഇറ്റ് ഇസ് എ ക്വാണ്ടിറ്റി വിച്ച് ഇസ് ഹാവിംഗ് ബോത്ത് മാഗ്നിറ്റ്യൂഡ് ആൻഡ് ഡയറക്ഷൻ. Okay, vector is a quantity which is having both magnitude and direction. Okay, so basically it is a rotating vector. So this what this vector will do, vector will be rotating. Okay, it is a line, it is a scaled line represent an AC quantity that has both magnitude and direction. Okay, so what is it is a vector, it is a vector quantity. Okay, again I will tell you what is a scalar quantity. Scalar quantity is a quantity which is having only magnitude. Okay, for example, one object of mass 50 kg. So it is a magnitude. Okay, it is having only magnitude. This is scalar quantity. But if you say about uh, the term velocity, velocity means it will be or displacement something like that. It will be having both magnitude and direction. Okay, it is moving with a speed of 15 kilometers per hour in the north direction. So that means it is having a magnitude and direction. So the phasor quantity is such a quantity which is having both the direction and magnitude, and this is a scaled line actually. Okay, I think you understood that. Okay, so it is a vector. We basically understand that the phasor is a vector. That means it is having both magnitude and direction. Uh, like term velocity, because velocity, if someone says velocity 50, I'm moving with velocity of 50 kilometer per 50 kilometer per hour in the north direction. That means in that north direction, it is moving with a velocity. That means it is having both magnitude and direction. So phasor is also a vector. It is a rotating vector. That is very important. Rotating vector. It is not placed like a normal vector. This vector will be rotating. Okay, and okay, again we will see little more detail. Okay, you can just note the point when I'm explaining. Okay, this one point you can write like this. Okay, this is one point. What is that? This is a rotating vector. You can write like that. This is a rotating vector. Okay, has both magnitude and direction. Only the important points you can write in the notebook. Okay. Then what we are when we go a little bit deeper into vector, vectors are assumed to pivot at one end around a fixed zero point known as point of origin. That means if you have a vector, that one end of the vector, one end of the vector is fixed at one point. This point is known as point of origin. Okay, and then okay, so again I will read. Vectors are assumed to pivot at one end around a fixed 0 point known as point of origin. So this point is known as point of origin, while the arrowed end representing the quantity. Okay, so we will see arrowed. We will extend this line, and at this end there is an arrow. Okay, so the arrowed end representing the quantity, and it rotates in anti-clockwise direction. Okay, with an angular velocity omega. So it is rotating in not clockwise direction. It is rotating in anti-clockwise direction, and this anti-clockwise direction is considered as positive rotation. Okay, so it is rotating in anti-clockwise direction. Okay, how it is rotating with an angular velocity omega. Okay, again we will learn. We will revise. Okay, uh, vector. We know normally vectors are used to represent like this. So vectors are represented like this. You can see uh, this on the top of this page. You can see the vectors are represented like this with an arrow end. Okay. So what is a phasor? So phasor is a rotating vector. So what is the specialty of this rotating vector? One end is fixed. Okay, at a 0 point. What is the name of the 0 point? Point of origin. And what about the arrow end? This this arrow end actually represents the quantity. It rotates in anti-clockwise direction with angular velocity omega. സോ ഈ ഒരു പോയിന്റ് വെച്ചിട്ട് എന്ത് ചെയ്യും ഈ വെക്ടർ അതായത് ഒരു പോയിന്റ് വൺ എൻഡ് എന്ന് പറയുന്നത് ഫിക്സ്ഡ് ആണ് അല്ലേ സോ വൺ എൻഡ് ഈസ് ഫിക്സ്ഡ് സോ വിത്ത് ദ റെഫറൻസ് ടു ദിസ് പോയിന്റ് ദിസ് ആരോ എൻഡ് വിൽ ബി റൊട്ടേറ്റിംഗ് ഇൻ ദ ആന്റി ക്ലോക്ക്വൈസ് ഡയറക്ഷൻ ആന്റി ക്ലോക്ക്വൈസ് ഡയറക്ഷനിൽ ആരോ എൻഡ് റൊട്ടേറ്റ് ചെയ്യുന്നുണ്ടാകുന്നു ഓക്കെ സോ ദാറ്റ് ഈസ് the basic explanation of phasor. Okay, so what is the positive rotation of phasor? Positive rotation means rotation in anti-clockwise direction is known as positive rotation. If it is rotating in clockwise direction, it is opposite. But it is negative rotation. Okay, you can see how a phasor is or how a sinusoidal AC quantity is represented using phasor. You can see that point of origin here. You can see the point of origin here. So this is the point of origin. So look at the circle. Okay, I'm drawing the point of origin here. So this is the point of origin. You can see the vector here or your phasor here. This with an arrow end. Okay, it is with an arrow end. So it will be rotating in anti-clockwise direction with an angular velocity omega. So we all know that sinusoidal quantity is represented in the radian form by x-axis omega t. So this is what angular velocity omega. Omega is actually angular velocity. Okay, omega is angular velocity. So I can use the same angular velocity in the phasor so that when the as per the instantaneous value of this waveform, this phasor also will rotate. Okay, as omega is changing, the phasor will be rotating in the anti-clockwise direction. Okay, again I will tell you. You can see there is a waveform and also phasor representation. Phasor. Okay, one end of the phasor is fixed at point of origin, and it is having opposite end and arrowed end. So now if I ask what is the length of the phasor, എങ്ങനെയാണ് നമ്മൾ ഈ phasor-ന്റെ ലെങ്ത് കണ്ടുപിടിക്കേണ്ടത്? Okay, length of the phasor is the peak value of the waveform. Okay, phasor-ന്റെ ലെങ്ത് എന്ന് പറയുന്നത് വളരെ ഇമ്പോർട്ടന്റ് പോയിന്റ് ആണ്. The length of the phasor is the peak value of the waveform. You can see here. So if it rotates like this, and finally if the phasor comes at this point, so it will be like this. Okay, it will be like this. Okay, you can see that the length of the phasor is equal to the peak value. Peak value എന്ന് പറഞ്ഞാൽ എന്താണ്? From the 0 position zero reference axis to maximum value in the positive uh, axis, okay, positive direction or positive half cycle. So ഇപ്പോഴും നിങ്ങൾക്ക് ഡൗട്ട് വന്നില്ലെങ്കിൽ ഞാൻ വീഡിയോ കാണിക്കാം. So you look at this video. So as the waveform changes, you can see that the phasor is rotating. Okay, ഇത് ആനിമേഷൻ പോലെ കാണുന്നുണ്ടോ? റൊട്ടേറ്റ് ചെയ്യുന്നത് കാണുന്നുണ്ടോ നിങ്ങൾക്ക്?
Sir.
Yes, sir.
Now, okay, now I will pause in between. Okay, now. Wait. Okay, now look at the phasor. Okay, now it has reached zero. That means waveform is going to start next positive half cycle. You look at the that means sine. If you represent the waveform using equation Vm sin omega t, that is now the value of sine is 360. That means it comes to zero. Okay, that means Vm sin omega t, Vm sin 0. The total instantaneous value is 0. Okay, here also you can see that the phasor is the length of the phasor. What is the length of the phasor? It is the peak value of the waveform. Okay, and it also at the position 0. Now, look at this waveform. From 0, it has moved to 90 degree. Okay, from 0, it has moved to 90 degree. That means when the peak value of positive half cycle will come, when the angle become 90. Okay, sin 90 is 1. So V is equal to V of t is equal to Vm. Okay, so in that case, you look at the phasor. Phasor also has displaced 90 degree. And again, you can see that. So it is okay. Almost it has passed 180. 180 means this phasor also has passed 180 degree, and it rotates like this. Okay. So as the omega, so we know that instantaneous value. Okay, I can write the expression here. V is equal to instantaneous value of an AC quantity. V is equal to, or V of t is equal to, V of t is equal to V m sin omega t. So this instantaneous value actually depends on the value of omega t. If omega t is 0, that means sin 0, the instantaneous value is 0. Okay. If omega t is 90, instantaneous value is 1. When omega t is 90, sin 90 is 1, instantaneous value is Vm. Okay, so you can write V of t is equal to Vm. V of t is equal to Vm. So when omega t is 90 degree, V of t is equal to Vm. Omega t is equal to 0 degree, V of t is equal to 0. Like that, when omega t is 180 degree, again sin 180 is 0. Okay, you will get the value from this expression itself. That is the expression of sine wave. Okay, so now what I want to tell you is when depends on the angle omega, the phasor will be rotating within this circle from based on the point of origin. And what is the length of this phasor? The length of the phasor is exactly same as the peak value of the waveform. What is the peak value? Peak value is the positive maximum or negative maximum from the reference axis. നമ്മൾ പഠിച്ചിട്ടുണ്ട് പീക്ക് വാല്യൂ എന്താണ്. Okay. So അതാണ് length of the phasor and depends on the value of omega, this phasor will be rotated. Okay, this is how we can represent a phasor from a AC quantity. Okay. So what is the use of this phasor? Okay, we will learn this topic now. Phasor, using phasor, we can easily do the calculations. Okay. So phasor is actually a quantity which can be represented in complex form. Complex forms means you know that there will be imaginary axis, real axis, etc. So there are different methods to represent a phasor. One is rectangular form or Cartesian form. You can name it both. In both the way you can address the form or Cartesian form. Okay. So when it is represented in rectangular form, a phasor, okay, I can write this x plus jy, x plus jy. So x is the value in real axis and j is a quantity. What's the value of the j? It is square root of -1 and y is imaginary axis. So I can represent, if I represent a phasor in a rectangular form, I have to write the expression like this: v equal to x plus a. So this is one example. So there will be x-axis, there will be y-axis. This x-axis is called the real axis. Real axis, and y-axis is called imaginary axis. Imaginary axis. So when I'm representing a value, for example, I have taken a point here. You can see the point in the market. So what is how to represent this vector quantity? So this vector I can represent like v is equal to, you just go and check what is the value of real axis. If one division is 1, you can see that 1, 2. So in real axis, the magnitude is 2. So I can write 2 plus, then I can write j. Then what is the value in imaginary axis? I can say 1, 2, 3. So this particular phasor can be represented like this: v equal to j. So this is how we will represent a phasor in a rectangular coordinate system or Cartesian coordinate system. Plus jy, where x is the real axis value, y is the imaginary axis value. Okay. Which is the next form? Polar. So in polar form, a phasor is represented in this way. R at an angle phi or theta, both you can write. Okay. R at an angle phi. Okay, where R is the radius and phi is the angle. Okay. Phase angle. So how it is represented? You can see that polar form is represented in a format like this. Okay, here suppose if I want to represent, if suppose and this is a Phasor quantity. Let's suppose this is a Phasor quantity. In polar form, it is represented in a format R at an angle phi. Now you can look at this diagram. What is the value? This is the point of origin, right? Point of origin is this one, central axis of this one. Then you can see that first circle, there is 1, 2, 3, 4, 5, 6. So value of R is 6. Then at an angle, you can see 0 degree here, 180 degree here. Total, you can see that the entire circle is of 360 degree. And from 0 degree, what is the phase angle? That is what we are going to see. Now you can look at phase angle. This is 0 with the from the reference angle. Your quantity is at this position, at this angle now. So what is this angle? Pi by 4. So you can represent this phasor quantity by an angle pi by 4. Or you can represent, what is pi? Pi is actually 180 degree, right? Pi is actually 180 degree. So what I can do the calculations also. 6 at an angle, 180 divided by 4 is how much? 180 divided by 4. 180 divided by 2 is 90. 180 divided by 4 is 45. So I represent that quantity 6 and at an angle 45 degree. Okay, so these are the methods, two important methods or most commonly used method to represent a phasor. Okay, again I will tell you, phasor is a quantity, it's a vector quantity or it is a rotating vector. So what is the specialty of vector? It is having both magnitude and direction. So for this AC quantity, okay, actually vector is an arrow. Okay, so one end of the arrow is fixed, and that fixed point is known as point of origin. The arrowed side of the phasor will be rotating with an angular velocity omega. So the rotation, if it is in anti-clockwise direction, the rotation is called positive rotation. If it is in clockwise direction, it is called negative rotation. Okay. Then how to represent a phasor? There are three methods. One is a rectangular form or Cartesian form. In that a vector is represented v is equal to x plus jy, where x is the real axis value, y is the imaginary axis. So in a you can represent it in this form. And next one is polar form, where it is represented using v is vector v is equal to r at an angle phi, where r is phase angle, sorry, r is magnitude and phi is phase angle. And the last one is triangular form, where it is represented in this form. So what is the vector? Vector is equal to this combination of both polar form and rectangular form actually. R e raised to j phi. This is more complicated. Okay, r into e raised to j phi, where e raised to j phi means it is cos phi plus j sin phi. E raised to j phi, what is the formula? Cos phi plus j sin phi. Okay, so normally for this module we will be dealing with polar form and rectangular form. എല്ലാരും നോട്ട് ചെയ്ത് വെക്കുന്നില്ല ഇതൊക്കെ?
Sir.
ഒരാൾ മാത്രമേ പറഞ്ഞിട്ടുള്ളല്ലോ.
Yes, sir.
Okay. Okay, this is we have already discussed R at an angle theta, or you can write R comma theta, both are correct. So here you can see it's the same thing what I'm going to do, explain. Okay, so this is called pole. The center point is called pole, and this is the reference 0 degree. And if you want to represent a uh, point 5 comma or 5 at an angle pi by 4, you can note that this is pi by 4. And what is 5? 1, 2, 3, 4, 5. You can note this point. So this is the face. Now, is there any relationship between rectangular coordinate system and polar coordinate system? That is what we are going to discuss. Okay. എന്തെങ്കിലും relation ഉണ്ടോ? Suppose if you want to convert a quantity, a phasor in polar form, sorry, okay, a phasor in polar form to rectangular form, or a phasor in a rectangular form to polar form, is there any method, or is it easy to convert? Is there any formula to convert it? Because why I am telling this one is, whenever if if you want to add or subtract two phasors, okay, ശ്രദ്ധിച്ചു കേൾക്കാം, നിങ്ങൾക്ക് രണ്ട് വെക്ടർ ആഡ് ചെയ്യോ, രണ്ട് ഫേസർ ആഡ് ചെയ്യോ സബ്സ്ട്രാക്ട് ചെയ്യോ ചെയ്യണമെങ്കിൽ it will be very easy if you do it in rectangular coordinate system. ആഡ് ചെയ്യാനും സബ്സ്ട്രാക്ട് ചെയ്യാനാണെങ്കിൽ നിങ്ങൾക്ക് ഏത് ചെയ്യാനാണ് എളുപ്പം? റെക്ടാങ്കുലർ കോർഡിനേറ്റ് സിസ്റ്റം, അതായത് എക്സ് പ്ലസ് ജെ വൈ വെച്ചിട്ട് ചെയ്യുന്നതാണ് നിങ്ങൾക്ക് എളുപ്പം. ബട്ട് ഇഫ് യു വാണ്ട് ടു മൾട്ടിപ്ലൈ or divide two faces, then it will be very easy for you to do it in polar coordinate system. നിങ്ങൾക്ക് ഏതെങ്കിലും ഒരു ഫേസറിൽ മൾട്ടിപ്ലിക്കേഷനോ ഡിവിഷനോ ചെയ്യണമെങ്കിൽ അത് ഏത് ചെയ്യുന്നതാണ് വളരെ എളുപ്പം? പോളാർ കോർഡിനേറ്റ് സിസ്റ്റത്തിൽ ചെയ്യുന്നതാണ് എളുപ്പം. സോ ഫോർ ന്യൂമറിക്കൽ പർപ്പസ് you need to convert these spaces from rectangular coordinate system and polar coordinate system. ഓക്കെ, നമുക്ക് ഒന്നും കൂടെ സ്റ്റാർട്ട് ചെയ്ത് നോക്കാം അല്ലെ പെട്ടെന്ന്. അതായത് ഒരു എ സി ക്വാണ്ടിറ്റീനെ നമുക്ക് എന്ത് ചെയ്യാം? ഒരു ഫേസറായിട്ട് റെപ്രസെന്റ് ചെയ്യാം. എന്തിനാണ് ഫേസറായിട്ട് റെപ്രസെന്റ് ചെയ്യുന്നത്? കൂടുതൽ അനാലിസിസ് ചെയ്യാനും ഒബ്സർവ് ചെയ്യാനും ഒക്കെയാണ് എ സി ക്വാണ്ടിറ്റിനെ ഫേസറായിട്ട് റെപ്രസെന്റ് ചെയ്യുന്നത്. സോ എന്താണ് ഫേസർ? ഫേസർ എന്ന് പറയുന്നത് റൊട്ടേറ്റ് ചെയ്യുന്ന വെക്ടറാണ്. വെക്ടർ എന്ന് പറഞ്ഞാൽ നമുക്കറിയാം അതിന് ഡയറക്ഷൻ ഉണ്ടാവും, മാഗ്നിറ്റ്യൂഡും ഉണ്ടാവും. ഓക്കെ, അപ്പൊ ഇനി ഫേസർ എടുക്കുക. ഫേസറിന്റെ ലെങ്ത് എന്ന് പറയുന്നത് എ സി ക്വാണ്ടിറ്റിന്റെ പീക്ക് വാല്യൂ ആയിരിക്കും. പിന്നെ ഈ ഫേസർ എന്താ ചെയ്യുക? ഇത് റൊട്ടേറ്റ് ചെയ്യുക അല്ലെ. എങ്ങനെ റൊട്ടേറ്റ് ചെയ്യാം? ആന്റി ക്ലോക്ക് വൈസ് ഡയറക്ഷനിൽ റൊട്ടേറ്റ് ചെയ്യുക. എങ്ങനെ, എത്ര സ്പീഡിലാണ് റൊട്ടേറ്റ് ചെയ്യുക? ഒമേഗ, ആംഗുലർ വെലോസിറ്റി ഒമേഗ സ്പീഡിലാണ് ഇത് റൊട്ടേറ്റ് ചെയ്യുക. ഓക്കെ, പിന്നെ നമ്മൾ പഠിച്ചു there are three methods to represent a phasor. Phasor or vector is both, the representation are common for both vector and phasor. Okay, so there are three methods: rectangular coordinate system, polar coordinate system, and triangular coordinate system. Okay, in a rectangular coordinate system, it is represented like vector v is equal to x plus jy, where x is the real axis value and y is the imaginary axis. And in polar coordinate system, it is represented like r at an angle phi or r comma theta. Both you can use, not an issue. Now what we are going to do is we are going to find out whether any relationship between this polar coordinate system and rectangular coordinate system. So suppose if they have given you the value of x and y, that means you know what is the coordinate rectangular coordinate system value, because this x and y എവിടുന്നാണ് ഈ x and y വന്നത്, ഈ വെക്ടർ റെപ്രസെന്റ് ചെയ്യുന്നത് റെക്ടാങ്കുലർ കോർഡിനേറ്റ് സിസ്റ്റത്തിലാണ്. അതിൽ നമ്മൾ എങ്ങനെ എഴുതുക, x plus jy ആണ്. So I got value of x and y from this coordinate system. ഓക്കെ, അതെന്തായിരിക്കും നമുക്ക്. സോ നമുക്കറിയാം ഇവിടെ റിയൽ ആക്സിസ് ഇവിടെ ഉണ്ട്, imaginary axis ഉണ്ട്. So x, what is the value of x? X is the value in the real axis, y is the value in the imaginary axis. So ഇങ്ങനെയാണെങ്കിൽ r കണ്ടുപിടിക്കാൻ എന്തെങ്കിലും ഫോർമുല നിങ്ങൾക്ക് അറിയോ, പറയാൻ പറ്റുമോ ആർക്കെങ്കിലും? r കണ്ടുപിടിക്കാൻ what is the formula for r? നമുക്ക് ഈ ഒരു വാല്യൂ അറിയാം, ഈ ഒരു വാല്യൂ അറിയാം. എന്താണ് ആറിന്റെ വാല്യൂ വരിക? ആറിന്റെ ഒരു ക്ലൂ കൊടുത്തിട്ടുണ്ട്. നമുക്ക് അഡ്ജസന്റ് സൈഡ് അറിയാം, ഓപ്പോസിറ്റ് സൈഡ് അറിയാം. എന്താണ് ഹൈപ്പോട്ടന്യൂസ്? ബിക്കോസ് ആർ ഇസ് ദ ഹൈപ്പോട്ടന്യൂസ്.
Adjacent square plus
r is equal to square root of x square plus, okay, adjacent square plus square root of adjacent square plus opposite side, അല്ലേ? Square of opposite side. So it is x square, square root of x square plus y square. Okay, നമുക്കറിയാം hypotenuse square is equal to adjacent side square plus opposite side square. So hypotenuse square is nothing but r square. Hypotenuse is r and hypotenuse square is r square. And adjacent side is x. So adjacent side square is x square. Opposite side is y. Opposite side square is y square. So from this formula we can write r is equal to square root of x square plus y square. Okay. ഇനി അടുത്തത് നമുക്ക് എങ്ങനെയാണ് ഇപ്പൊ പോളാർ കോർഡിനേറ്റ് സിസ്റ്റം നമുക്ക് റെപ്രസെന്റ് ചെയ്യണം, അല്ലെ? എക്സും വൈയും നമുക്ക് തന്നിട്ടുണ്ട്, ആറും തീറ്റയും നമ്മൾ കണ്ടു.
കേൾക്കാവോ?
കേൾക്കാം.
ഓക്കെ. അഭിറാം പി പി. ഓക്കെ. അഭിജിത്ത്.
പ്രസന്റ് സാർ.
ആദിത്.
പ്രസന്റ് സാർ.
അജയ്.
പ്രസന്റ് സാർ.
ആകാശ്.
പ്രസന്റ് സാർ.
അലോക്.
പ്രസന്റ് സാർ.
ദിൽരാജ്.
പ്രസന്റ് സാർ.
ദേവ് കിരൺ.
പ്രസന്റ് സാർ.
നന്ദന,
Present, sir.
പാർവൺ,
Present, sir.
പ്രത്യുഷ്,
Present, sir.
സായന്ത്,
Present, sir.
ശ്രീകാന്ത്,
Present, sir.
Vishal,
Present, sir.
Rajita,
Present, sir.
Vaishnav Sethi.
Present, sir.
Okay, the answer കിട്ടിയോ നിങ്ങൾക്ക് എങ്ങനെയാണ് ടീച്ചർ കണ്ടുപിടിക്കുന്നത്?